so in this video we're going to explore one more problem on linked list, and this is basically going to be some kind of a merge between two linked lists. So let's just give it a name. So this is we're going to call this as a shuffle merge. So this is going to be called as a shuffle merge of two linked lists. Okay, and the problem is as follows: that you're given two singly linked lists. And you're asked to merge these two singly linked lists by alternating between every node in your linked list. Okay, so let me draw a picture. Let me draw a picture just to make this a little bit more clear. So let's have a first linked list here. So this is my node 1 of my first linked list. This is my node 2. This is my node 3. And let's just give some values to these elements. Let's just call this value 1. This is my first node with the element 1. This is my second node with the element 2, and then I've got my third node with the element 3. And I'm just going to connect these nodes up. So this is my first singly linked list, and I'm going to have let's just have head 1. Let's just have head 1, which is the head of my first linked list, and let's just create a second linked list. So this is my second linked list, and this right now is going to have let's just give some values. Let's make it 7, 13, and 1. So this is my second linked list, and I'm just going to give some values here. So this is going to be 7, 13, and 1, and let's just connect these nodes up here. So that's my next references on every node, and this is going to be head 2 pointing at the head of my second linked list. And what the problem is asking you is to write a function that takes these two single linked lists. And what you need to do is you need to produce this singly linked list, which is going to be a merge between head 1 and head 2. So starting from head 1, you're going to take the first node of head 1, which in this case is 1, is with this node with the element 1. Okay, so let's just select that color here. Okay, so that's my first node of my first linked list, and I'm going to keep on alternating. Meaning I'm going to start with this node over here, and then look at head 2, and then go back to the second node of my first linked list, and keep on alternating until I've got every single node of my linked list merged up. So let me just make my none here. So this is the end of my linked list, which is referred to by the reference containing the none. Okay, so the picture is going to look like I start with this node with the element 1. This is going to point at my next node. Now this is going to contain the value. This is going to contain the value 7, and let me just draw my 6 nodes here. So which is a merge across the first linked list and the second linked list. In total, I should be having 6 nodes here. 1, 2, 3, and this is my 4th node, my 5th node, and my 6th node. Okay, and I'm just going to merge them up here. So this is the next reference here, and the value that these are going to contain is 1, 7, 2, right? 1, 7, 2, 13, 13, 3, 3, 1, and then finally I've got my none. Okay, so this is the very high level problem description. This is what you're asked to do here. Now, of course, these linked lists could have different sizes. It doesn't necessarily need to be that both the linked lists will contain the length being equal to each other. So if either of the singly linked list, if either one of these singly linked lists, so this is my linked list 1 and this is my linked list 2, and after you start performing this shuffle merge operation, if either one of these single linked lists runs out of nodes, okay, all the nodes should be taken from the other larger linked list and merged at the end. Okay, so what does that mean here? So let me just give you another picture here, and in this I'm just going to use the same color. So this, let me just draw a line here, and let's just create a simple explanation. Let's have these two nodes here with the values 1 and 2. So this is with the value 1, value 2, and let's connect these up. Let's just connect these up here. So that's none, and this is pointing at none, and let's have this as h1, my header 1. Okay, and then if I've got my header 2, and the header 2 is pointing to the second linked list, and let's have this as let's just have this as 4 nodes, just to get the picture what it's supposed to do. Okay, and let's just give some values here. So let's make this as 7, 13, 13, 1, and 9. And again, let's connect these up. So this is none. These are my next references, and the last reference on my last node will be pointing in this case at none. And okay, so what would the shuffle merge look like for this thing? Okay, so just the intuition is starting with, I'm going to start from head 1. Starting from head 1, I'm going to go this way. Okay, and after 13, because there is I've already run out of my nodes in the first linked list, I'm just going to append whatever is the remaining nodes of my larger linked list towards on the end. So the picture for this is going to look like that's my 1, 2, 3, 4, 5, 6. I've got a total of 6 nodes here. So 1, 2, 3, 4, 5, and 6, and I'm going to connect these up here. Okay, so this is at none, and then finally I'm just going to give some values here. So this is going to be just starting from 1. This is going to be 1. This is going to be 7, 1, 7, 2, 2, 13, 13, and it's not clear here. Let's just make 13 over there just to make it clear. This is 13, and then finally 1 and 9. Okay, so so in this case, let's just have let's just call h3 header 3, right? And header 3 is going to point at this linked list, which is going to be a merge of head 1 and head 2. Now it's completely fine. The solution I'm going to present to you in the next video is that we're going to assume that I'm just going to modify these linked lists. My linked lists are mutable to begin with, and I'm not going to create an entirely a third brand new deep copy a linked list. I'm not going to do a deep copy of any of these nodes here. I'm just going to use my reference manipulation. I'm just going to manipulate my references, and I'm going to present this solution using a little on my idea of loop invariant. Okay, so we're going to use loop invariant, and I'm going to have a non-recursive solution presented in the second part of this video.